Today's my lecture topic is propellant feed system in rocket propulsion. The selection of a particular feed system and its components is governed primarily by the application of the rocket, its size, propellant, thrust, flight program, duration, cost experience, and by general requirements of simplicity of design, ease of manufacture, reliability of operation, and minimum weight. Gas pressure system. One of the simplest and most common means of pressurizing the propellants is to force them out of their respective tanks by displacing them with high pressure gas. This gas is fed into the propeller tanks at a controlled pressure, thereby giving a controlled propellant discharge. For low thrust and short duration, such as for research vehicles or sounding rockets, a feed system of this type is preferred. Although the propellant tanks in gas pressure feed system have to be very heavy to withstand the high internal pressures, the overall system weight can be lower than that of a turbo pump system for these applications. Because of their simplicity, the rocket engines with pressurized feed systems can be very reliable. A simple pressurized feed system consists of essentially of a high pressure gas tank, a gas shutoff and a starting valve, a pressure regulator, propellant tanks, propellant valves, and feed lines. Additional components such as filling and draining provisions, check valves and filters are also often incorporated. After all tanks are filled, the high pressure air valve is remotely actuated and admits air through the pressure regulator at a constant pressure to the propellant tanks. The purpose of the check valves is to prevent a mixing of the oxidizer with the fuel when the unit is not in an upright position. The propellants can be fed to the thrust chamber by opening valves. When the propellants are completely consumed, the pressurizing air serves also as a scavenging agent and cleans lines and valves of liquid propellant inside. The variations in this system, such as the combination of several valves into one or the elimination and addition of certain components, depend to a large extent on the application. If a unit is to be used over and over, such as an aircraft or plant rocket, it will include several additional features such as possibly a thrust regulating device and a tank level gauge. They will not be found in air expandable single shot unit, which may not even have a tank drainage provision. Pressure balance equations are usually reduced from a simple diagram. The chamber pressure PC plus the pressure losses in the propellant piping and valves, injector and cooling jacket, plus the pressure drop in the gas lines and the regulator have all the pressure in the tank. Second on a feed system is called turbo pump system. The turbo pump rocket feed system pressurizes the propellants by means of pumps, which in turn are driven by turbines. The turbines derive their power from the expansion of hot gases. A separate gas generator additionally produces these gases in the required quantities and at the desired turbine inlet temperature by means of a chemical reaction similar to the reaction in the combustion chamber. A turbo pump feed system is are usually used on a high thrust and long duration rocket units. They are lighter than other type of these applications. Their weight is essentially independent of duration. A typical and relatively turbopump system consists of a typical liquid propellant rocket engine with a turbopump system. Each block has its own input and output systems.